Hey, what's up you again guys? This is Paul from Maharlikans Code. I'm a web developer, programmer by profession. I'm from the Philippines but working here in Singapore as a software engineer. And today I will walk through with you guys on how to use these Golang channels. As in our previous discussion that we would like to discuss on the Golang channels to synchronize the works of our workers, which is what we call here in Golang is Go routines. So now we want to synchronize multiple workers that will work with the same function, but it will gather all the result into one using this channel, guys. So channels can be what they call channels can be a type conduit. So through this means that you need to declare. It's like before you can use the channel type as usual in declarations such as like a maps, slices or something, guys. Then you need to declare make channel something. Same with the map, then we can make map also, and then in this case it's a channel type. So right now the channel is the main driver for all the Go routines that will manage all the flow of the Go routines, and it's return the value to a specific channels. And the channels also have buffered channels. The buffered channel, this serves as our queues. This one's like, if you know Redis, this one is like a queue also. Like this is like what they call in out or first in first out type of thing, like a inventory system, like a FIFO. This is a first in first out queues. If you use this buffered channel, there are two types, guys, of channeling in Golang channels. This one, the buffer channel, should be there is a capacity for buffer channel, for how many capacity, like a 10 or something, but by default we can set 1 or it's like that, guys. So the buffer, then it will qualify as a buffer channel. So let's dive into it, guys. So I can explain in the simplest way that we can explain. So let's dive into it. Okay guys, welcome back to the channel, and I prepare a bit here as usual as our main function here, and then we will create a simple function, guys, just to sum up the thing, and then or we can just okay, let's sum up, and then we use s, and then okay, we just want the slice of integer, so we can accept integer here, guys, multiple integer. And then to declare a channel, guys, it serves as similar type like a string, integer or something, guys, but it's different way, guys. Then this channel returns integer, guys. So okay, then that's I need to check, hold on, and then need to do the normal function, guys. Okay, I just normally sum up here. I just want to make another total something, and then I put 0 here, initialize the value, guys, and then I need to for loop. This one is just a sample what you call function, guys, to illustrate to you what that we would like to share the workload for each Go routines. So okay, plus example, then b. Okay, this is the thing, and then I will return here, guys, that the C here is the channel ready, guys. This is the channel initialization. Before you can use, don't forget to initialize. It's like a normal type, guys, in Golang. The weird thing is this one, guys, the less than symbol and then the minus symbol, the dash. Okay, I will explain to you later. This one will serve as our what they call, we will send the total, guys. Here is the total, send the total value or total value send the send the total value to our channel name C. So this is our channel C, guys. So the meaning of this, whatever the arrow pointing there to C, this value will send to the channel, guys, the data. Whatever the coroutine is calling this sum function, then it will, whatever the result here, the calculation, then it will store to the channel C here that we initialize as this variable C. Whatever name you can put here, guys, but for the sake of simplicity, normally they will put a two shortcut name, shortcut letters. Then whatever this arrow, guys, it will throw this one, because this is the integer, guys. Remember, again, you need to match again whatever the type here. This channel will accept only integer, guys. And this is the thing, so it can accept integer. Of course, we need to throw integer value also, guys, from whatever it is here. The default of throwing this is the default of the local variable is integer also, unless you need to variable here, guys, and then declare for float 64 or whatever, then your channel must return something, whatever is as usual. In our previous discussion, that our function will also return like a float 64 or a string or a slice of a string, guys. So these are all the things. So right now, our channel, in this example, our channel that we created as our one of our arguments here, that we want to accept integer value only. So of course, you want to throw the data as an integer value also, guys. So please remember that one. Here you can always change whatever the type, as an example, like a string also, whatever you want, guys. So now we throw the value, whatever value here, as an integer to our channel that accepts integer value. This serves as our data, guys, to be sent out. Okay, later we will receive this, because the channel is a send and receive. Please remember that, guys, is a send and receive kind of thing. So this is the normal flow of a channel. Always there is somebody send, and then there is a receiver. Again, we need to throw to our function to capture the value here. As an example, guys, I would like to put the S there, for example, because our function, the sum function, requires an array of integer. So we would like to initialize here, and then we key in the value, guys. For example, 2, 4. You can key in multiple values here, guys. This is a slice of an integer. And then for example, I put 1000, guys, so we will total all these things. Okay, so this one probably 2 plus 6. This one is 12, 24. So 10, 24. 10, 24 should be the result, guys. Okay, we proceed. For loop again, we need to search, need to scan all the value there, and then by ranging this, guys. So okay, so we will save, then we will calculate here. Okay, so this one, no, guys, hold on, this one wrong. This one should be in another function. So right now I want to create a channel here, guys. Remember, please make always this channel. Before you can use, you need to declare a channel, guys. Same with a map or slice string, all these things, guys. So okay, I will declare also the same thing as channel as integer, that I can accept integer data that will be flow into these channels. So only I can accept integer values. It's up to you, guys. For this example, is we accept only integer value. If you want, you can accept also string values into your channel. So the data flow would be all integer value only in these channels. You can create multiple channels if you want, guys, but this channel is dedicated to an integer value. So channels also is it's similar to a function, guys. You have some dedicated channel for whatever reason you in your programming, then you can do that here in making a channel. Like if you have creating a chat or notification channel or whatever, guys, then you can create a new channel for that, solely for that channel purpose. That is the best way we can do in the channeling our Go routines, guys. So this is the flow of Go routines here. So now we want to create without this one is non-buffered channel, guys. This is not a buffer channel. So later on we will discuss that one. This one is just a normal one. As usual, you know already how we can declare Go routines in Golang. We just have this magic word, which is Go, all small letter. And then here in this example, guys, we would like to share the workloads, as I mentioned in our previous discussion regarding the Go routines, that the Go routines you can deploy how many workers you want in one calculations or one it's like if you have a heavy calculations in your functions, then you can deploy how many Go routines or workers to to achieve whatever the heavy calculations in that functions. So if you deploy 10, then these 10 workers will work for you synchronously by using the channel. Then we can return with the same result, guys. We will declare 2 Go routines for this calculation. So let's continue. Just put a slice, guys. Then the length. I just want to divide the workload for these 2 workers, guys. So hold on. Go sum. Again, I need to s, and then the length of the string s, and then I will divide the 2 guys into 2 workloads. Okay, guys, so we continue, and then I divide the 2 in this example, guys. So okay, guys, so this example is from the Google itself, guys. So from the Golang main documentation. So I just want to illustrate to you on how we can divide this workload based on the example, guys. So this part is we will receive the whatever we receive the thing, guys. So we will receive the data here from the functions, from the sum functions, from function. Okay, guys, so right now we would like to print this data, the x and the y, and then we just calculate this to x plus y, guys. So now we can display this result. And let's see what will happen, guys. The calculation should be there. We will calculate all these, like for example, now as you can see that the x and the y, our x, as you can see that the channel here, this channel, guys, you remember that the c, the declaration of the channel here, same as the integer, because well, in this sum we require as integer. You need to match everything, guys. You need to, this one is we sending the data here to the sum function, and then that sum function, it requires a channel, guys. So it requires a channel as one of the parameter, and then our string here, we just divide the value here, guys. So we just divide the calculation like 2 plus 4 here, and then a 6 plus 2 or something, guys. It will just continue. Here is the first 2 is we use another Go routine then to call this function, and then later on, as you can see that the calculation remembers there as we increment only. There's a simple incremental value variable here to calculate the sum, and then the rest of our functions here with the second Go routines captures another calculation, which means that the rest of the numbers like the 612 and 1000. Right now we have 2 workers deployed for this calculation. And after this, we declare local variables, like for example the x and y, and then we require, then this one is a one line of code, guys. You can also multiple line, but we can save a lot of rows. Now we throw whatever the C will return here, guys, from this function here. Okay, so right now it returns the x value, which is the 10 what do you call the 10, so 1018, 1018, and another one is the 6. As you can see, the first number, the y, I think we need to run again. Let's see, we will observe. Yeah, it's a fixed value, guys, so the arrangement is the same. Right now we need to create these two variables here, and then this one is just in output, but here is the real addition, guys. So we, as you can see, that the workload has been shared between two Go routines, but we manage these two Go routines to result with its results into to synchronize the two Go routines, guys. This one is a blocking one, because this one will finish up first and then the other one will be the next one. Then it will return the value, guys. So this is how the Go routines, this one is non-buffered channel, guys. So this one is a blocking what do you call a blocking channel. This one will do the work first, and then the second one will do the next run. This one is a blocking, guys. So as you can see, the calculation is working properly. Now I want to show you another one. Is we can close another channel. This one I just copy paste, guys. Just to illustrate to you, when we close another the channel, so you just issue the close syntax here, and then would like to run this, that we want to close this channel, guys. Here is a closing one, like we use channel. We can also close the channel, guys, so no worries here. Here is a buffered channel, guys. If you want to make a buffered channel, then you can just create another one, like if you want. So I would like to create a new channel, guys, for this SAM one, and then a chan in again, but this time is a buffered channel. I put 10 or 1, this one to make it a buffer channel. So buffer channel is a queuing system, guys, for Golang here. The another way of channeling, guys. This one is more popular to use the channels in Go, because it's a buffered what do you call this, a queuing system. It's a first in first out way of system, way of the flow of the channels, guys, the flow of the data of the channel. So whatever the request there, it will queue up based on the first there, then the first out also. So this is the buffer channel, guys. So the 10 there, for example, this one all integer is a capacity, guys. So whatever the 10 is what do you call this is the number of capacity that you can run with the same channels there. I mean how many queue can be queued at the same time, guys. You can put 100, it's up to your requirement, guys, but this one will deploy like 1,000 also the capacity. But after after it fulls, after it reaches to the 100, then it will be a blocking one or something, like it will queue up, guys, until it will block the capacity. This one you cannot change. This one is a hard-coded one. You cannot change this on the fly. So this one you can change later, guys. But the buffered one, normally if you have a very much traffic, for example in this channel, you can put 100 or 10. Even if 10, guys, it cannot even consume this, because the Go routine is very fast And but of course it depends on the workload, but normally the Go routines is very fast. It's just a millisecond or something, a nanosecond, it can finish the one task. It cannot even to reach up to the 10 capacity, but if you want you can put 100 also, it's no worry. So right now we can assume again this new function that we want to use. Okay, but this now is a buffer channel, it's a queuing system. Please remember that, guys. It's a queue. And then what do you call, okay guys, another way I type for you to capture our time. Another way is we declare another channel, which is a buffer channel. As long as you put the capacity or something at the end, then this is our capacity. This channel becomes a buffer channel, guys. So right now we do the same calculation, but of course we have a closing here to close the channel, but no worries, it will auto reopen again when there is a new request. So if it's idle mode there, then you can close the channel, guys. This is the best practice. Okay, so if you run this, it's the same return all that calculation, guys. So the same function, but I added this close channel here to close which channel. After this the task has been executed and then pass on to the channel there, the data, then you can automatically close this channel, so that it will not just idle there or just hanging there. It's a best practice that you can close the channel, guys. But after you create again, there's a new send request, then it will automatically open for you. That one you no need to worry about it. This is how the buffer channel is working, guys. It's a first in. This is the first send data, so it means this means has been queued to this channel, to our buffer channel, and then it will process this Go routine and then will return again, and then after that it will close. So this how the buffer channel and the Go routine synchronize each other, guys, by using the channels. So later we will have a small maybe a chat application or notifications in your in your application, in the web applications or whatsoever your programs or Go programs will run. You always have these guys. So okay, now another way, guys, is we can use this another way, guys, is there is another channel that I created, and I captured our time, so I fill in all the information for you. No worries, this code will be in your in our source code there. So okay, guys, so this is the thing, guys, I prepared for you. This one is very common when we have a web development already, guys. So this one is another channel type, guys. This channel will accept the type there is OS signal. This is OS signal, guys. If you receive this kind of signal like a sig kill or a sig term, normally this is a control plus C, guys. This is our an OS levels kind of signal, guys, so that this channel can accept OS signal. This OS signal can always listen all these sig in, sig kill, sig quit, or sig term. These are all built in Golang there under the OS package, guys. This OS package is very powerful. Then you can have this interrupt. When the user clicks or type in the control plus C in the keyboard, then our application will be it will be quit. This will block here. What I mean is this channel, this C2 channel here, can always listen. This channel is dedicated to OS signal channel. As I mentioned, you can always create multiple channels at the same time, guys. But this one, every channel is a dedicated channels for any purpose of your application, Go application. So this time I created a new channel here, just channel, then the type there is OS signal, and then the capacity, this one is a buffer channel. Always use the buffer channel, guys. This one is more more convenient and more what do you call, this one is a first in first out, guys. So the flow of this channel is a first in first out, first request and then it will be first out also. It's a FIFO kind of thing, guys. So I like the buffer channel. Most of the programming in Go is we always use buffer channel. So you always put the capacity, even though this one is a 1 only, guys, because this one is very seldom these channels can accept and these channels can what you call can receive only or seldom receive a control C signal from the server or from the guy who controls C your application or something, guys. So okay, this one will these are all built in from Golang, guys, so no worries about it. The signal, then notify, whatever. Then this channel receives here. This one will not is a blocking until here. The code will not proceed to these guys. Later I will run. As if you see this kind of thing here is a blocking, guys. That's why I put a note something here. Okay, so this one will block. This one will not execute. Whatever below scripts here, please remember that this kind of code, the channel C2 here, it will block, guys. If you have this one is very useful because whatever code you have here, it should not be executed until he receive this notify signal. Will receive a OS interrupt, which is all these values, guys. Most specifically, if you one of it is the control C. So let's try this. Okay, I will run. Okay, hold on, guys. Oh, sometimes like this, guys. You need to enter the thing, the OS. Then the arrangement is always on the next row. Okay, with CLS. Okay, we run again, guys. As you can see that the cursor is there, guys. It never terminates our application. It never terminates because here it's a blocking, guys. As you can see that this context that without this one is a context background, guys. In Golang also is another way of Golang. This one is another package that we want to discuss probably in our future discussion, guys. So as you can see, it never come to this part now, which is OS exit. If I put a note here, the FMT, this one you never see this until you receive the OS signal, which is a control C. Right now it's still running, guys. This is very important when you have a web server or your application runs in the network or something like this. One is always listen. It always run now. Your application is running, especially if you're a web server or a file server or a network type of programming that they always run. Same thing with our Go copy. You remember in our previous discussion that there is what they call the Go copy there. Now our server, we use this. Anything we want to run within our application. Now if I control C, what will happen? As you can see, it proceeds here, guys, because this one is a blocking one. Whatever code, please take note of this. Whatever code you don't put here below on this, if you have this blocking signal, normally, guys, this kind of thing is we put normally at the bottom of the whatever the main function there. Normally these kind of things will put in the bottom of your script. Like this, what I did here is always at the bottom. This one is very useful. Then you can have your own logging here, like a shutdown or something. Like you can check out on our Go copy series there. You can have a look on this part, what I did there. So right now as you can see the control, because the OS interrupt receive this kind of signal from the user, which is from the device, from the keyboard of the user there, of the computer, of the server or whatever, guys. Your Go program is currently running. So it receives a control C. After the control C, then it will proceed here. Then the OS exit here. is something like this, guys. So deeper cancel all these context. We will have a separate discussion about this context, guys, so no worries about it at the moment. So we focus on the channel, guys. So this is the buffered channel. Buffered channel is a queue kind of thing, guys. It's a queuing system. It's a queuing channel in Go. So normally we will do this, guys. There is a buffer that, and then the capacity there. So I hope you learn a lot here, guys. There's these channels is a quite huge topic. There are more examples in more advanced examples. Like if you want a non-blocking channel, then you go with the select channel there or something, guys. That one is more we will discuss further probably in our next discussion, going to be more on another way of channeling, but this one is will suffices us in this in this discussion first. So maybe the one is more on the advanced topic, guys. So we will, no worries, we will deal with that in our future videos. At the moment, a lot of information we cannot digest at the moment. So slowly, but we learn here in Maharlikans code, guys. So this is how we can distribute the workloads. As you know that even though one function, most specifically if you have a heavy calculation, guys, you can always use a channel and the Go routines to work for you. You can deploy thousands of workers, hundreds of workers. Workers means it's a Go routines, guys. Same with this channel here. Then you can deploy. Here you can have a multiple Go routines here, but one Go routine is one or two Go routines is more good enough for application, guys, unless you have a very heavy traffic of your website or the servers are very intensive checking. Then you can deploy thousands of workers, the Go routines, or hundreds of Go routines. Okay, guys, so I hope I can explain to you more on this regarding the channel. So thank you so much for watching my video. Okay, guys, that's all for today's discussion about these Golang channels. Then and then we know how we can use and manage these Golang channels for our applications. This one, guys, is always present in Golang programming language, especially these channels and Go routines. So this will manage everything from our web server or any workers that we want to run constantly, or checking something in real time. This can handle multiple requests at the same time, guys. So using these channels, it will just manage all the Go routines of thousands or millions of Go routines you can just deploy. Probably 1,000, guys. If you have a large ecosystem, then you can, it's possible. There's no limit for you to deploy these Go routines. Okay, guys, so that's all for today. I hope you learn here in Maharlikans code. And if you're new to my channel, kindly subscribe to my channel, and please consider subscribing so that you can receive more videos like this, and then you can learn a lot here in Maharlikans code. See you in my next video, guys. Thank you so much for watching. May God bless us all. Thank you, and bye bye.